On August 25, 1764, an enthusiastic astronomer, Charles Messier, was searching for a comet in the skies of Paris. He was scanning the night sky like a black canvas with his telescope, and suddenly he noticed a faint, hazy glow. It didn't look like a bright star, but rather like a cloud-like object in which individual stars were not visible. It was so faint that at first he thought it might be a comet. But over the next few nights, when he studied it in more detail, he found that it was stationary in the same spot. It didn't have a tail like a comet. After that, Messier recorded it in his famous catalogue. Everyone thought that it was just a large cloud of gas inside the Milky Way, but in the sky it was nothing short of a mystery. For years it was just a number. M33, one of the hundreds of such objects listed in Messier's catalogue. And then came the year 1920. Edwin Hubble planned to observe it again through the telescope. He discovered Cepheid variable stars in it. Cepheid variable stars are those stars that brighten and dim at regular intervals. And from here, the stars could be measured farther, and since then, the Triangulum galaxy has fascinated scientists. It is the third largest member in our local group after the Milky Way and Andromeda, but that doesn't mean it's just an ordinary galaxy. Its spiral arms, the gas, and the ratio of stars present in it. It is so unbalanced that it seems like this galaxy is still being born. This galaxy is not only alive, but it's also changing. It is moving towards Andromeda. Maybe after 3 to 5 billion years, these two galaxies will merge together. But there are still many questions about M33. Is it really our neighboring galaxy or a wandering world that got trapped in our local group? This is the story of the Triangulum galaxy that makes you stop and think. When you see the Triangulum galaxy for the first time, it feels as if a child has drawn swirling lines in the sky with blue and white colors. It's not a perfect spiral like our Milky Way. And pulled them apart. But between these broken spiral arms, there are many huge H2 regions where stars hundreds of times heavier than the Sun are being born. Astronomers call them by names like NGC 604, NGC 595, and IC 142. But actually, these huge H2 regions are large clouds of ionized hydrogen where the process of star formation begins. Astronomers say NGC 604 is so big that our Orion Nebula would fit inside it several times over. It's a balloon of gas 1,500 light years wide, filled with ionized gas that's hundreds of thousands of degrees hot, and dozens of O-type stars are shining together inside it. In the images from Hubble and James Webb, it looks like a huge red-pink bubble, as if another galaxy is being born from inside a galaxy. But the most astonishing thing about this in the middle, there's a monster with a mass of 100 million solar masses sitting there. But nothing like that is seen at the center of the Triangulum galaxy. All observations until 2024, they indicate that there's no supermassive black hole there. It should also have a central black hole just as big. This rule applies almost everywhere except for the Triangulum galaxy. Here, some scientists believe that either the black hole never formed or it was thrown out in a massive collision a long time ago, and both possibilities are frightening. Still, this galaxy is an expert at making stars. Its star formation rate is about 0.45 solar masses per year, a little less than our Milky Way, but much more than Andromeda. The rest is still there, whereas our galaxy has already used up half of its gas, which means the Triangulum galaxy is still young. And this youthfulness, in a way, makes it dangerous, because it's moving toward Andromeda at 180 kilometers per second. They will merge in Andromeda, but before that, the Triangulum galaxy is teaching us something. It tells us that galaxies also have different natures. Some are calm, while others are violent. Darkness rules at the center of some. By the time the light from some of them reaches us, it is already 2.74 million years old. That means we are not seeing them as they are today, but as they were when our ancestors on Earth were just learning to stand upright. On Earth, humans In such a vast nursery, blue giants, stars 200 to 300 times heavier than our sun, were burning together. Their ultraviolet rays were heating the surrounding gas so much that it reached millions of degrees Celsius. Matter. In the Triangulum galaxy, it is only 1/3 of that. This means that the grip of gravity on stars and gas here is weak. That's why its spiral arms are so open and fragmented with no per cubic parsec. But if we look at the center of the Milky Way, this figure is thousands of times higher. This could mean that perhaps the Triangulum galaxy does not yet have a galactic core. It is still an incomplete It is possible that there is a supermassive black hole present at its center. It could be very small and currently dormant. Some scientists believe that Triangulum is a rare example, a pure disk galaxy in which the bulge is still. The star formation in the Triangulum galaxy is currently quite rapid. In the next few billion years, this process of star formation will become even faster. As a result, the mass and density of its central region will increase significantly, and then perhaps its center will also become dense enough to form a black hole. For now, we are learning a lot from this galaxy about how our Milky Way and almost every galaxy formed in this universe evolve in their early stages. We have learned a lot, but perhaps it is the law of this universe that the more we try to understand it, the more mysterious it becomes. The Triangulum galaxy is much the same. all the gas and dust have formed. The rest, more than 90% of it, is dark matter, but even then, it is only half as much as our Milky Way. This lack of dark matter deepens its mysteries even further. It seems as if this galaxy has hidden itself behind a veil of dark matter. In 2024, the James Webb Space Telescope's NIRCam and MIRI instruments together discovered 793 completely new stellar objects in its southern arm. Most of them are still in the protostar stage. Some are only a few 100,000 years old, and many of them have masses of around 8 to 30 solar masses. And in the next few million years, these stars will become O-type or B-type blue giant stars. This shows that the process of star formation in this galaxy is quite fast. But if we look toward its center, we encounter a major paradox. The very center of this galaxy. This remains its biggest mystery. In 2023, ALMA and the Very Large Radio Telescope observed its core in millimeter and centimeter wavelengths, and the results were astonishing. No strong radio source was found there, no jet was found, and no compact object was found either. Finding the core of a large galaxy so mysteriously empty definitely raises questions. After all, did something really terrible happen to this galaxy? Maybe a very terrible collision happened, which distorted the shape of its spiral arms, and all the mass from its center was stolen. Even its supermassive black hole. According to this, even if a supermassive black hole exists at its center, its mass won't be more than 3,000 solar masses, which is why some scientists also call it a black hole-less spiral. But the mystery of not having a black hole in this galaxy can be explained in several ways. The first theory says that maybe the Triangulum galaxy hasn't yet felt the need for a supermassive black hole because it already had so much gas that the stars formed from it were able to stabilize the galaxy's disk on their own. The second theory says that a long time ago, maybe 8 to 10 billion years ago, the Triangulum galaxy had a violent collision with a much larger galaxy. Because of that collision, its main central black hole must have been thrown out. The theory of such recoiling black holes already exists in our science, and the Triangulum galaxy could be living proof of it. Along with this, it is continuously moving towards Andromeda at 180 kilometers per second. If we calculate from today, these two will collide in about 3.5 to 4.5 billion years. In the beginning, both of them will overpower each other, pulling and destroying each other's spiral arms. Then, for millions of years, the gravitational dance between these two galaxies will continue. And in the end, this galaxy will completely merge into the Andromeda galaxy. Sometime after their merger, our Milky Way will also join that collision because we too are moving towards Andromeda at a speed of about 110 kilometers per second. The merging of all three galaxies will create a very massive elliptical galaxy which astronomers have already named Milky. But Triangulum's life isn't that long. It will be swallowed up first. All its stars, all its gas, all its stories, and perhaps even the storytellers themselves will be absorbed into Andromeda's maw. And we won't even be able to see its last glow from Earth because by then, our sun will have already become a red giant and all traces of humans will have vanished from Earth. Any humans who survive will have either migrated from Earth or settled in distant regions somewhere within the solar system. If you also want to see this unique galaxy, you'll have to go somewhere far from the light pollution of villages and cities, where the sky is completely clear, and then you'll be able to see it in the sky. A faint and blurry glowing spot will be clearly visible in this constellation about 1.5 degrees southwest between Alpha Trianguli and Beta Trianguli, like a faint oval-shaped cloud. It will appear at around 6.5 magnitude, which means it will be very difficult to see with the naked eye. But as soon as you use a pair of 10 by 50 binoculars, the view will change for you. Let your eyes adjust to the darkness for 10 to 50 minutes, and then by zooming in 30 to 50 times, you will have entered this unique galaxy. From 2026, the Vera C. Rubin Observatory will scan the Triangulum galaxy again every 3 nights. In 10 years, we will be able to record the changes in brightness of more than 10 million of its stars. Every supernova, every microlensing event, every rotating gas cloud, we are going to capture all its data. James Webb will capture the complete 3D spectrum of its center by mid-2026, and then maybe we will get an exact answer to this. And this game will keep going on like this in this infinite universe for infinite time. But until then, the Triangulum galaxy is still there and alive. It's our good fortune that we are located about 26,000 light years away from the center of our galaxy, in an area that is lifeless, desolate and isolated, but the center of our galaxy, the Milky Way, is much more dangerous and frightening. This galactic center, filled with intense radiation, gravity and mysteries, is in no way ideal for us humans. But what if our planet were in such a galactic center? So what would happen if our Earth somehow reached the center of the galaxy and somehow managed to survive there? What would our experience be like there? What changes would happen in humans, and would we get stuck there? These are some of the many questions that often come to our minds when we think about an alien civilization that lives at the center of a galaxy. Today we will try to put ourselves in their place. So friends, buckle up and strap yourselves in, because in today's space journey, we are going to travel through millions and billions of stars to reach the center of the galaxy. Milky Way, that is Akash Ganga, our very own galaxy, in which about 100 billion stars are spread across an area of nearly 100,000 light years. In other words, even if you travel at the speed of light, it would take you 100,000 years to go from one end of the Milky Way to the other. From this, you can imagine that our galaxy is very large in size, and besides that, it contains billions of stars, planets, and gas. They are not stationary in one place. This whole system is dynamic and constantly evolving. If we talk about our entire galaxy, then the Milky Way is traveling through space at a speed of about 1.3 million miles per hour. The Sun is also orbiting the galaxy, and our entire solar system is included in the list of those billions of stars that are part of this galaxy. Do you know what the most fascinating thing about our galaxy is? It's its shape. There's a big bulge in the middle, and its arms are spiral-shaped. The spiral arms are the places where new stars are born. This is where most of the stars, gas and dust gather. Away from all the chaos, this is the very region where our solar system is also located. At a distance of 26,000 light years from the galactic center, this distance is really huge. Our solar system also orbits the galactic center, and it takes about 230 million years to complete one orbit of the galaxy. Now just think, about 65 million years ago, there were dinosaurs on Earth. And since then, look at how far we humans have come. But our solar system hasn't even completed a quarter of an orbit around the galaxy yet. Actually, the position of our solar system in the galaxy impacts our life in many ways. For example, because of our position, we are exposed to a lower amount of cosmic radiation. Asteroids and other types of impacts are also quite rare, and because of our location, we are able to enjoy such amazing views of the universe and the galaxy today. If we weren't so lucky, even if Earth could see the galaxy, we are really lucky. If we weren't so lucky, then we are really lucky. If we weren't so lucky, then we are really lucky. If we weren't so lucky, then we wouldn't be so lucky, but we are really lucky. Like right now, it protects us from harmful radiation. Does its magnetic field work there as well? The answer is no. It would be like using a small umbrella to protect ourselves from a big storm. The magnetic field of our Earth can't protect us from the dangerous radiation there at all. So the conditions there are not suitable for humans to live. But there would definitely be some creatures there that would adapt themselves to those conditions and evolve to survive there. We have seen such creatures even in the extreme environments of our own Earth. Many such creatures have been found in extreme pressure zones under the oceans, in extreme heat in volcanoes, and in extreme cold at the poles that can survive in such extreme conditions. But what if we humans could evolve to survive and live there? What would happen if we learned to live in those conditions? We humans? Our skin will evolve in such a way that it can protect us from radiation. Plants will grow in a different way, because there the sky will always shine with the light of Arbo stars. We will evolve to live there, but even then, things will not be easy for us while living there. Even then, intense radiation will be our biggest enemy. Because of the radiation, our DNA will keep getting damaged continuously. This might be the biggest punishment for living there. Apart from this, mutations will keep happening in our DNA very quickly. And this is what scares us humans the most. Because of mutations, you never know what a person might turn into over there. The fear won't be just from humans. Animals and plants will also keep falling victim to mutations. Because of this, we'll keep seeing changes there every moment. And these are just a few examples. We're not even talking about the extreme cases here. It's possible that while living there, our bodies might undergo metabolic changes. It could also happen that our bodies have to adapt to process food and other resources more quickly. Because of this, the growth and size of our bodies will also increase, and the trees, plants, and animals around us will become much larger than normal. Many bioluminescent creatures have been seen on Earth that glow more brightly in higher radiation. Such creatures will shine even more in the radiation levels there. You can imagine yourself at night in such a forest with the whole place glowing green and blue because of these creatures. That experience would definitely be amazing, but at the same time, it would also be very scary. But radiation is just one reason. But now we'll talk about another major change you'd see there. Yes, gravity, gravitational attraction, gravity is very strong at the center of the Milky Way. Because right at the very center of the galaxy, a huge monster is sitting there, a supermassive black hole. A black hole 40 million times heavier than our sun, which is called Sagittarius A. Now that will be our neighbor. Amazing. Now the biggest fear will be that it might swallow us, or we might get crushed in its gravity. If we're lucky, nothing like that will happen, but don't think that the disaster has been averted. The gravity of the black hole will still trigger earthquakes and volcanic eruptions on Earth. Nothing will remain stable on the planet. No permanent construction will be able to withstand it, and we might have to build floating stations to live on. Or houses will be built to live in that can withstand such massive earthquakes. To put it simply, we will have to fight such disasters every day, protect ourselves from sea waves every day, face storms every day. In other words, we will have to compete with nature for our lives every single day. The worst part of this story is that even if you want to leave that planet, sorry, you won't be able to get out of it. You are trapped there forever. Because launching rockets in such intense gravity won't be easy, and in that intense radiation, our electronics won't work either. Here, gravity won't just affect things. According to Einstein's theory of relativity, because of such intense gravity, the flow of time there will also be slower. That means living near the galactic center, people living near the galactic center would age more slowly. You will see that over there, in the sky, the positions of the stars will appear to change rapidly. And another thing it means is that we won't be able to navigate in space there. First of all, we will be surrounded by billions and trillions of stars there, and all those stars. It means that even if you get lost in space, you still won't have any tool to navigate. And even if you get lost in a dense forest on Earth, only the creepy animals of that forest will be able to find you. Humans probably never will. Alright, but now let's take a look at some amazing views that we would see while living there. In the galactic center, there would be numerous molecular clouds around us, where stars are being born. Seeing those areas would be a unique experience. But if we look at all of this together, our world in the galactic center would be completely different. There would be some sights there that we have never seen here before, but still, this journey was quite interesting. To understand this, beyond the faint light of our sun, there is a very mysterious world hidden beyond the last planet of our solar system and even farther than the mysterious world of the Oort cloud. In this infinite and mystery-filled dark space, there is a place. Alpha Centauri is a big challenge. Our closest star system, a shining light that inspires hope in the night sky that maybe we are not alone in this universe. There is a hope about our home that if one day Earth is no longer habitable, this star system could be our new home. But along with it, there is also a troubling distance. What is the reason that reaching there seems almost impossible for us? And if we ever manage to combine our will and technology to cross this long interstellar distance, what will we find there? A new world or another disappointment that will remind us how small we are in the face of the universe. Get ready for an astonishing journey to Alpha Centauri, because here we are going to unravel many mysteries of Alpha Centauri. This journey will be amazing, will seem impossible, and will confront us with a truth that might force us to think about our universe and our own existence. The stars do call us, but at the same time, they also warn us that the path to them is surrounded by darkness. Alpha Centauri is It's not just a star, but a system filled with complexities and wonders. It has three major celestial bodies. Alpha Centauri A is a star very similar to our Sun, and it's officially known as Rigil Kentaurus. The second star in this system is Alpha Centauri B. It is also called Ptolemy, and the last one is the mysterious Alpha Centauri C, which is also known as Proxima Centauri. It is a red dwarf which orbits around these two at a distance of 0.2 light years. A lone wandering star which is right at the edge of its stellar family. Proxima Centauri has a secret, a planet named Proxima b. It was discovered in 2016. This rocky exoplanet is very close to its star. It's just 0.049 astronomical units away, but still, it's in Proxima Centauri's habitable zone. So, could this be a second home for our human civilization? Is it possible? Or are there some conditions here that will always keep this planet shrouded in mystery? Proxima is also our closest known exoplanet. At just 4.246 light-years away, in cosmic terms, it seems really close, but being this close still means a distance of 40 trillion kilometers. This distance is so vast that even light, which is the fastest thing in the universe, takes 4.3 years to cover it. For humans like us, who exist in this universe for just a brief moment and are bound to our slow spaceships, this challenge becomes even greater. Reaching Proxima b is not just a journey, it's like making a bet with the impossible. So why do we dream of Proxima b? Maybe because it's a mystery waiting to be solved? A piece of the puzzle that fits perfectly into the grand narrative of our existence. But before we set foot on this unknown land, we have to face a harsh reality. A reality that asks us questions we might be afraid to face. Just think about it. The distance to Proxima Centauri is 266,000 times greater than the distance between Earth and the Sun. It's about 103 million times greater than the distance between the Earth and the Moon. Voyager 1, which is humanity's fastest interstellar spacecraft, would take 75,000 years to get there. 75,000 years. By then, our civilization might have turned to dust. Or maybe we would have long forgotten that we ever launched probes called Voyager. The record-breaking Parker Solar Probe, which travels at a speed of 700,000 kilometers per hour, even it would take 6,500 years to complete this trip. These numbers are not just frightening, they remind us that in terms of technology, we are still at a very early stage of development. Reaching Alpha Centauri is not a simple challenge. It will be a journey that will demand breaking through and going beyond the limits of physics, engineering, and human imagination. And yet, when we gaze into this infinite universe, a strange question arises. Are we meant to cross it, or does the universe hold some secrets that perhaps we shouldn't unlock? In 1905, Albert Einstein changed the way we understand our reality with his special theory of relativity. Any object that has mass will not be able to surpass the speed of light. This is not just a suggestion, it's a cosmic rule that cannot be broken, one that is embedded forever in the fabric of space-time. When an object accelerates, its energy turns into mass. The faster it moves, the heavier it becomes, and then a point will come when it can't go any faster. So his 80 kilogram mass will increase to almost 2 tons. The closer you get to the cosmic speed limit, the harder it becomes to increase your speed. Crossing the speed of light is like trying to jump over a wall of infinite height. No force, no power can take you to the other side. Even if we reach the speed of light, Proxima Centauri, it seems impossible. Reaching such a speed is not just a technological challenge. This is a battle against the very nature and principles of reality, one that is impossible for us to win. A glimmer of hope, time dilation, and yet this universe is full of paradoxes. When a spaceship travels close to the speed of light, a strange phenomenon occurs. Time dilation. For a spacecraft heading towards Proxima Centauri, time flows more slowly for its crew. For an observer on the ground, this journey may seem to last for decades or even centuries. But for the travelers inside the spacecraft, it will feel like only a few years. But Centauri is 4.246 light years away, and reaching it would take about 4.47 years. But for the crew, due to time dilation, this journey will feel like only 1.39 years. The faster the spacecraft travels, the smaller this difference becomes. But if the spacecraft travels at 99.9% of the speed of light, the crew will experience only 2 weeks during a 1-year journey. And if the speed reaches 99.9999% the speed of light, then a journey of thousands of light years for the crew. First, this phenomenon raises a profound question. Can relativistic travel open the path to interstellar exploration? Maybe, but time dilation is not a miracle. The required energy to reach such speeds is also For exploration, all of these challenges are still enormous. At such speeds, even a thin layer of interstellar gas would become a deadly plasma. For both the spacecraft and its crew, the empty space, which once seemed calm and completely empty, would become an invisible battleground. A battlefield where no spacecraft has survived yet. Time dilation does promise to take us to distant stars, but it also brings with it deep and mysterious barriers. Limitations of time dilation. As we saw earlier, to take a mass close to the speed of light would practically require infinite energy, and so far we haven't found any propulsion system that can make this possible. And even if somehow this energy problem is solved, even then, a spaceship traveling close to the speed of light would find space to be a very dangerous place. Space is not empty. It's actually filled with countless wandering atoms. Sometimes these gather in complex forms like gas and dust clouds, galaxies, stars, and planets. And sometimes they keep wandering alone as single atoms in this infinite universe, between two hydrogen atoms in a cubic centimeter of space. The probability of collision is a different matter, and the certainty of an enormous flow of particles colliding with the spaceship during its journey is a completely different matter. At low speeds, the particles are harmless, but with acceleration, they rain down as a dangerous shower. These can cause severe damage to the spacecraft in the form of projectiles and highly penetrating ionizing radiation, and the atmosphere inside the spaceship becomes extremely radioactive for the crew on board. Particles that travel close to the speed of light acquire so much energy that they become a threat to any form of life. At such high speeds, even passing through a very thin nebula cloud can destroy the entire spaceship. Social and temporal disconnection, a lonely future. Even if we overcome all the technical challenges, an impossible problem will still remain. Time dilation will have a devastating effect on the relationship between the spaceship and the home planet. For the crew aboard the relativistic ship, time will slow down drastically, but on Earth, the clock will keep ticking at its usual pace, so what feels like just 11 years for the crew will be very different. For the people left behind on Earth, that time will turn into hundreds of thousands or even tens of millions of years. This harsh truth presents us with an existential dilemma. Astronauts who embark on such a journey will have to leave behind their world, family, friends, and even their culture forever. And when they return, Earth will have completely changed for them, Or perhaps it may not even be habitable anymore. The society they once left behind would have been lost in the sands of time, either transformed into something alien or completely vanished. The spaceship will no longer be a means of exploration, but will become their own small world, drifting alone through time and space. The effects of such temporal isolation can also be seen in the idea of the fictional United Federation of Planets like in Star Trek. The cultural and technological synchronization necessary for trade and cooperation will fall apart. Would a commercial enterprise have the motivation to send cargo on a journey where there would never be any connection with the sender again? Such a journey would not be a transaction, but rather cargo that has neither an owner nor a destination. Under the rules of Einsteinian relativity, any spaceship embarking on such a journey would actually become a self-sustained world, completely different from its origin, drifting away from its purpose. So, would this sacrifice be worth it? This somber conclusion aligns well with Enrico Fermi's famous paradox. If such civilizations exist, then why haven't we found them yet? Maybe the answer isn't that they don't exist, but rather in the cruel barriers imposed by the laws of this universe. Time dilation presents us with a harsh reality even if we manage to overcome these barriers. For the crew of a relativistic spaceship, time on their planet will continue to pass at its usual pace. Generations will pass, civilizations will rise and fall by the time the crew returns. Their world will have completely changed for them, or perhaps even completely disappeared. So then, what would be the purpose of such a journey? A mission to Alpha Centauri isn't just about crossing physical space. It will break those bonds of time and memories that connect us to humanity, that make us human. The Fermi paradox is a stark reminder. This conclusion leads us to a frightening and profound question, one that Enrico Fermi once asked. If advanced civilizations exist, then why haven't we found them yet? Maybe the answer lies hidden in the same limitations that we ourselves face. The distances between the stars are not just measurements of space. They are like strong fortresses of isolation. These are some barriers created by nature that hardly anyone would try to break. These barriers probably confine every civilization to its own celestial backyard, where dreams of interstellar expansion burn like a dying flame and eventually fade away. Alpha Centauri, despite being close to us, remains just a dream, one that only the truly courageous dare to pursue. And is it only for those who can sacrifice everything for their world? This points to the absence of visitors. This is a sign of the defeat of all those civilizations. Or maybe it's an even deeper warning that we are truly alone in this endless darkness. A new hope. With robotic explorers and light sails, we know that where humans can't succeed, maybe machines can. The future of interstellar exploration may be in the hands of robotic probes. Miniaturized marvels capable of traveling at fractions of the speed of light. Concepts like von Neumann probes, which can self-replicate and colonize, they could spread the essence of humanity to the stars. Or perhaps laser sails, which would be driven by focused beams of light. Lightweight probes can be accelerated to up to 20% of the speed of light, and with this, we could reach Alpha Centauri in just 21 years. These solutions are not part of science fiction, but are actually very close to our reality. This journey still won't be easy and the obstacles are huge, but humanity has never backed down from doing the impossible. Will these machines one day send us secrets that we never even imagined? Conclusion: the eternal mystery Alpha Centauri has always been a puzzle. a mystery at the edge of human reach. It inspires us to explore new worlds, but at the same time reminds us of our limitations. Whether we reach there in a century, a millennium, or perhaps never at all, the dream of Alpha Centauri will always inspire humanity to look up at the sky, ask questions, and move forward. In the end, the journey to the stars is not just about exploration. It's about facing an infinite and unknown universe and trying to find meaning in it. Are we meant to remain strangers here? Or maybe one day we'll become one with these stars. Whatever happens, this mystery will remain. Let us know what you think about it in the comments section. How did you like this video? If you enjoyed it, please like it and share it with your friends. For more videos like this, make sure to subscribe to the channel and turn on notifications. Friends, we'll see you again soon with another informative video like this. Until then, stay curious, be happy, and goodbye.